All right, hey folks, welcome to my session. My name is Dmitry Lyalin. I'm a product manager for Visual Studio Team Services, and today I'm going to talk to you about how to use Visual Studio Team Services and our cloud-hosted build agents to build your app in a cloud. We've also got Unity team integration that I want to show you as well, which is really great. So I'm going to jump right into it and get into the details. So first of all, what is Visual Studio Team Services? A lot of people hear the word Visual Studio, they assume this is a product that is focused on the IDE, the Visual Studio product itself, but actually this is a cloud-hosted DevOps solution. It has 5 major product areas that I'm going to talk to you about today, and we're going to demo only a few of them. So as a high-level overview, our product supports agile planning, we have Kanban boards, we have task management in the cloud for you. We have the ability to do source control across Git and TFVC, Git being the very popular one, industry standard implementation that will be part of my demo today. We also have CI/CD pipelines that enable you to do everything from continuously integrate with your source code as you're doing commits, all the way out through the release of your product to a cloud, such as Azure or even AWS. So we've got a great full end-to-end integration story there, all the way from planning through code. We also have other capabilities. We have things like package management, we have things like load testing, automated testing, unit testing, lots of things that you can do. We won't be able to cover all of that today. Today we're really going to be focused on the build engine and Git source control. So let's go ahead and take a look at those things. I'll close out to say that as a high-level concept, VSDs is very open. We have a marketplace. We inherently support things like GitHub, Git itself, Docker. We have great compatibility across all the platforms. We have hosted build agents for Mac, Linux, and Windows up in the cloud. And we're pretty freaking cheap. We're basically free for people that have teams that are 5 or less. We have free build agents, we have unlimited private Git repos, lots of great stuff. So that's the pitch, and visualstudio.com/VSDs is where you can learn more. But let's jump into the core of this presentation. So today I'm going to do 3 demos. I'm going to first of all go through the scenario of building a Unity application up in the cloud. So with Unity, Unity has their own service called Unity Teams, and they have build capability inside of that service. And we will show you how to integrate between our source control and their service and make it all work as a CI integration, so you'll be able to commit code in VSTS, and it'll go all the way out to their build and automatically trigger a build in their system, allowing you to see if everything is ready to be distributed. We're going to do a second demo. This demo is going to focus on monogame. Monogame is something that we can build inherently inside of our cloud-hosted agents. We have Windows agents, for example, that can build the Windows native or the UWP app or even the Android app. So it works really well, and we can do all of that without ever leaving VSTS. So I'll be able to demonstrate this right in our product. And then I'm going to end the demonstration by talking about how you can do builds of your backend service. It doesn't matter if your service is written in .NET or Node or Python or Ruby. That's really agnostic. All the components will work. You'll be able to plan against it. You'll be able to store the source code for it. You'll be able to trigger the builds for it. And if you wanted to, again, do the release stuff, but we're not going to demo that. I will also show, as part of that experience, the pull request mechanism we have built in. Because one of the things that we find in real sort of dev teams is that you don't want people just checking into master without having some review cycle. So we have a great interface for pull requests. Other folks like GitHub have also implemented interfaces around pull requests, but we have our own, and it's enforced by policy, and it's really cool, so I'm going to demonstrate that towards the end. So let's go ahead and jump into the very first demo. This is all the slides I'm going to torture you with today. So the first demo, we're going to close iTunes. We're definitely going to do that first. That's what happens when you hook up your phone to not die during the presentation. All right, so we're going to start off in VSTS itself. So let me put this up to full screen and show you VSTS. This is running in the web browser, so we've got VSTS as a fully cloud-hosted solution. You don't have to install anything. I want to sort of tell you how I got here, right? I created my account, I've logged in, I have all my code and everything committed, and I set up a dashboard, and that's what you're looking at here. So this is how most users of your team will log in to take a look at what's going on. With the work assigned to them, you can visualize the work on the dashboard. You can see what's going on with the builds. You can see how much work based on state you have assigned. You can create arbitrary markdown sections for putting like useful resources. You can see other team members. It's a fully customizable dashboard, and I just wanted to show that as an entry point because this is a real way for you to set up your team and get a sense sense of everything that's going on inside of your repository, inside of your build, inside of your releases, anything that's hosted within our product, you can visualize in this dashboard and even customize it yourself. So that's kind of a quick view, and also to show that this is interactive. So if I wanted to see something about a build, a particular build that succeeded or even worse, failed, I can actually click on that, and it's not static here. It will actually take me to the failed build, load it up, and I can see what went wrong there. In this case, I know what went wrong, so I don't have to figure that out, but I just wanted to show that dashboard is quite a useful thing. All right, so let's talk about the abilities within the Git ecosystem we have built out. Under code, you can see everything that is related to all the repositories, no matter what type of repository they are, that are stored inside of VSTS, inside of your team. So this is limited to the scope of your team. So in my team, I have the following repositories. I have a Lyalin Games repository. I mean, this is all just fake demonstration, so that's where I keep my backend service. I have a Toy Nightmare, which is a Unity sample game, and I have Chump, which is a mono sample game. So I have 3 different repos. They serve 3 different purposes, and I'm going to go ahead and jump into the Toy Nightmare one right now. So Toy Nightmare is a Unity game, and its source code is what you would expect for a Unity project. You can basically visualize it right here. You can go through it. You can look at the assets. You can go down to, let's say, scripts, UI, and we have visualization for things like C# with colors and everything, so you can really see your source code. But you can even do things like view history. So you can see how we got here, which commits caused it, and if there was a diff on it, you would even see file compare view. Maybe I'll find a file later to show you what that looks like. I'm going to bring my UI back so I can hit back. So that's really cool, and you also have things like search that's built right into our product. So let's say, in this case, we have a class called Friends Item Render, but let's say I was all the way back up here, right? I'm like, I know the class I'm looking for, I need to find it. We've built in things like, I'm gonna zoom in a little bit, like code search that lets you filter based on this different kind of classifiers here and find what you need to do. So if I say class, so I'm gonna do that right now, I'm gonna say class, and put the class name, hit enter, it's going to go ahead and find everywhere where it can find that class, and it's smart enough to actually find a class and not a string with that name in it. So it's actually quite advanced for anything that's built in C# or .NET. So those are just some cool things that we have inside of here for rendering the source code, for viewing the source code, for searching the source code, but we also help you out with things like the commits that are coming in and looking at the branches that were used to get here. So if you look at the commits, we can see the commit history of this project, and if you import a repository from GitHub or some other place, it'll take your history with you, so it works just like you would expect Git to work, and you have really rich ability to go into any of the commits, see which files are part of it, and see who did it. Try to find one. Here's one with some differences, right? So you have a left-right compare right here, right in the cloud, so it's really powerful UI for that. And then under branches, we have a list of every branch, both limited to like yours or all. If you had more than one branch, you would see all the branches here. So again, very powerful web UI that allows you to explore this quite a bit. Now, this is, like I said, a Unity game. So I'm going to go to Visual Studio right now, and I'm going to open up, I'm going to go to Unity, because I want to go through the way you would normally work. So here's my sample game. Certainly didn't make it. This is a sample from the Unity side that we've modified for a few things that we wanted to show. Real Unity game, the one that we've probably seen a million times if you ever looked at the samples that Unity provides. So that's not really important. What is important is showing you some of the integration we have back up to our DevOps service. So I'm going to go ahead and open the source code, and I'm going to make a change to this. So let's give it a second here. Just going to load the settings. And just like you would expect, Visual Studio starts, figures out which files to load, which projects that are connected to your Unity game. All right, so there they are. And what I'm going to do is I'm going to change one of the files, so it doesn't matter which one, right? So let's pick one random one here, and I'm really not going to make a big change. Not a big change, right? I'm not here to show you game programming, just the back-end nature of it for us from a DevOps perspective. So I've made that change, and I'm going to use, I'm actually going to use command line. Let's do that to commit the change out. So I'm going to go to my git command prompt. I'm going to go to Toy Nightmare. I'm going to do a git status. Sorry, 1 second. Make sure that I'm committing to the right place. Yeah, let's use the UI. All right, so I'm going to use the UI Visual Studio to do the commit. Same thing, no real difference here. So I'm going to not put a great comment, hit save, do the commit, and I'm going to sync that change up to the repo. All right, that should be done in a second. All right, all the changes got committed. So now let's go back to VSTS and take a look at that commit. So I'm going to go to my list of commits. And as you can see just now, there was a commit with a really terrible comment, and you can see exactly what was changed. But here's the cool thing. We've integrated this one. By integrated, I use that word very lightly. We basically connected it to Unity Team Build. So Unity has their own product, has nothing to do with Microsoft. We didn't build it. We didn't enable anything special, but they themselves have enabled this experience to happen. I'm just demonstrating how it can be configured to do so. So I'm going to open up in Unity Teams, the project, and I'm going to go straight to builds because it's the only thing I use in there. I'm going to go to configure, and I'm going to show you that I've configured it to be watching my repo in VSTS. So over an SSH key that I've configured inside of VSTS, which is really easy to do, well documented, I've configured it out to my repo, and I've told it to build 64 and 32-bit versions of this game, and Unity can certainly do that. So it has in here, if I open up Show Basic, I'll zoom in over here a little bit. So it has this auto build option, and it's basically watching for any changes inside of the source folder where you'd expect it to look, and just build out the game. Now this can take up to 7 minutes to trigger. When I was practicing right before, it actually triggered right away, which I found really funny because it never does that. But here it is. It has triggered before plenty of times. It really is building the game. You can download and run it. So you can have a true CI integration between the planning and the source code management that you're doing inside of VSTS, and it will flow very nicely into the build agent that Unity has provided. Unfortunately, the Unity engine is going to cost you some money. They require you to pay. We are pretty much free for this scenario. As one user, I don't have to pay for VSTS up to 5. It is free for everybody. So that's simple. All right, so that's kind of a quick demonstration of how we've configured it all to work, and I'll come back here later if I don't forget and show you that this thing really did trigger based on our commit of this really, really not important change that hopefully won't break anything. All right, so that was demo number 1. Let's go to demo number 2. So number 2, for this demo, we're going to go back to mono games. We have a mono game. Let me actually show you the mono game real quick, just to show you that is a real sample. Again, not a real game, but a real enough sample. So this is a project the buddy of mine created a while back, another Microsoft employee. The game is called, it's the monster game, it's called Chump. It has a couple of names to it, but basically it's a simple mono game. It has a shared project which has a bunch of code, and then it can be built out to Windows, Universal, and Android. And all of this is buildable inside of our hosted build agents. So in this case, we don't need the Unity build cloud because mono game is all .NET and Xamarin, and we can build all of that inside of VSTS. So I'm going to go ahead and show you that inside of VSTS now. I'm going to go in here, and again, this drop down in the top left lets me switch repos anytime I want. So I'm going to go ahead and switch to the Chump repo and show you that we have, again, lots of history, lots of code that's already checked in. And specifically, we have a build defined inside of VSTS that is going to trigger if I commit any changes to this repo. So I'm going to go to build definitions. And inside of the build definitions, I basically use the out-of-the-box template. So VSTS, let me explain this a little bit. It's a task-based build system. So you can come in here and you can basically hit new, and you have pre-selected templates, and you can use those to get started. I'll show you the one that actually works for mono game almost out of the box. But you can also completely customize it, and I'll explain exactly how much in a second here. So let's hit new just to demonstrate how much power this thing has. It supports out of the box not only our source control, but also GitHub, GitHub Enterprise, Subversion, Bitbucket, and even any externally hosted address, something that you can hit over the internet and Git repo. In this case, let's say I wanted to use ours. I can select the repository that I'm targeting. I'm not actually going to save this, but I'm going to demonstrate a few things through this quick example, just to show you this experience of templates. So, because mono game is basically a .NET desktop application as a starting point, at least, as the way to think about it. I used that when I was building my build definition. And it almost perfectly configured it for that scenario. So this is what I mean by task-based system. On the left here, by default, because I chose a template, there's a bunch of tasks. And the tasks are movable. You can literally drag them around. You can go ahead and click on any one of them, and there's all sorts of settings that you can change to them. You can build your own tasks. You can even build them and publish them to the marketplace. We have a lot of tasks that we've built into the product ourselves. So we have things like everything from .NET Core tasks all the way to uploading to FTP, Google Play capability integration. We have installing SSH keys. You can run Jenkins queries. There's so much here. I mean, I literally don't know everything that's in here. There's literally so many things that are available. And on top of that, we have a marketplace. So the marketplace is where our partners can publish anything they want. In fact, AWS publishes a first-class extension for our product, so something they maintain. I know Google is working on theirs as well, and we fully support Azure out of the box. So you're not limited to which cloud you want to use with our system. You're not limited to what you want to build with our build system. It is really flexible. We use VSTs to build everything inside of Microsoft, pretty much. So you have things like Minecraft, for example, right? They build on top of this thing. It's just one example of somebody that uses our build engine. And the way that we have it configured is that you have the ability to set up a trigger for continuous integration, and that's how we're able to commit a build, which I'm going to do in a second here, based on any changes that are happening to the chump game. So I'm going to go back to VS for a second here. I'm going to go back to this monster game. Again, I'm going to make a really insignificant change just to demonstrate the CI nature of it. So we're going to remove one letter here, nothing crazy. And we're going to push these changes after committing them. So we're going to go to changes real quick. Small change. I'm breaking all the rules of proper source code management here, but it's okay. And I'm going to push these changes up. All right, changes have gone up, and if I did not mess anything up, that should trigger our build. So we're going to go to builds. Yes, I'm going to leave because this was just a demonstration. I don't care to save that. And there you go. It's actually working. It's in progress. So my Mono game native build is in progress, and I can click right here to see what's exactly happening in there. So I'm going to do that and show you the rich nature of the information that we expose to you. Kind of again, I forget if I said this or not, but we have Windows, Linux, and Mac agents in the cloud. In this case, I'm choosing the Windows one. You can also take an agent that we have and install it on Linux, install it on Mac, install it on Windows, in your cloud, in Azure, in AWS, on a machine under your desk. As long as this service can, over the internet, hit it, we'll be able to trigger builds on it. We have teams at Microsoft that have certain equipment that they've purchased, so they use it for their builds, and they trigger it from the cloud. And then on top of that, they usually use some of our cloud-hosted agents as well. This gives you really rich information on what's happening. And this build, takes a bit to finish, so I'm not going to wait for it to complete. But what I do want to show is a completed build. So I'm going to go back to builds. And I'm going to go back through the history. So I'm going to use this thing right here to click on, the previous one that was completed for it. And I'm going to find the artifacts button. Bear with me one second here. Sorry, I was playing with these builds earlier, and it's a good chance I broke something. Yeah, this build did not create artifacts. Let me find one that did. It wouldn't be a real demo if I didn't have some kind of issues. That's fine. The best time I ever had was at one conference when the internet failed for my internet demo. That was really the best. After that, nothing really scares you anymore. Jeez, I wonder why it's not here. All right, well, I was showing this to myself earlier, but of course when I want to show it to people, it's not working. So basically there's an artifact button that appears. I must have broken the build somehow as I was messing with it. But the artifact folders will let you download everything that we built up in the cloud as a zip file. Or again, as part of those build tasks, you can configure it to upload it somewhere, put it on network share. You can send it up to Google Play Store. You can actually submit the build if that's what you want to do. Of course, some of those things aren't necessarily recommended best practices, but this is a very, very flexible build engine that lets you do whatever you need to do. And sorry I failed you in the last demo there, but trust me, it does work, and I'm sure I'm going to kick myself when I figure out what happened to that. All right, so for the next demo, our third and last demo that we're going to show today. So this demo is going to be all about the back end. So let me switch gears a little bit and go into VS Code. So this is a sample Node app that I've basically decided to demonstrate. And you don't build Node, but you can run a bunch of stuff against Node to make sure that your Node package is ready to be deployed somewhere, and you can package it up. So to that end, let me show you how that's configured inside of the cloud. I'm going to go back here. I'm going to go back to my builds, and I'm going to click on the game service one. So I can click right here on the dots, and I can say edit, and that'll let me show you all the steps that I've implemented inside of there. So what this does is it does npm install, but then it runs the unit test that the sample already has built into it. Then it installs the Azure Functions pack. I didn't build the sample, so I'm actually not sure why they needed that, but there's probably a really good reason. Then it runs a security check by running the run security check command. Again, these are all the various extensions I guess the person added on top of the baseline Node package. I'm not a Node developer, but I can show you that you can really customize this to be what you need it to be. And at the end of it, it creates an artifact that's ready to go. You can configure it with our release management system as well. That will push it into the cloud of your choice. Again, you can push to Azure, you can push to AWS, you can push it to an FTP server, whatever you would like to do. And it all just works. And maybe I can actually show what I wanted to show earlier through here. So I'm going to, why not just give it a shot? Because I'm just feeling silly that didn't work earlier. Let's click on one of these builds. They're completed. Yep, there it is. So that's what I was missing earlier. I'm going to zoom in a little bit just to show you. So when a build is successful, and when you're not me and you don't break your build, you get an artifacts button here. And this artifacts button, if I click on it, lets you download or explore. So I'm going to hit explore and show you that it created a zip file just like we intended. I've downloaded the zip file. I've looked at it before. It takes a minute or two. So it's pretty big because of all the Node packages and such. But really, this thing does work, and it gives you great traceability. The beautiful thing about the fact that this product is a suite of ours is you can use it however you want. So you can choose just to use build, let's say, or source control. But if you use the agile planning and you plan your work against the code you commit, and then you take that committed code and do the build, you can see all the way through, and you can have full traceability. You can click on a work item and see the builds that are triggered, the commits that were associated. It makes tracking work on a team of any size really much, much easier, and that's how we actually work. Microsoft uses this to build Windows. Microsoft uses this to build all the games that we build out of our studios. We build Xbox with this. We build our hardware with it. It's a planning tool. It's a code, storage tool. It builds releases, it has wikis, it has tests, lots of capabilities. And I want to show you one particular thing as kind of the last big demo, which is pull request experience that we have inside. So I'm going to go and make a change inside of this VS Code. Again, the changes I'm making are silly. As you can see, I changed this line like 10 times getting ready. So really fixed comment. There you go, I've done that. And VS Code does what VS Code can do. It detects it as a change. I'm going to go ahead and commit. Another change, sorry. I should be committing every 5 minutes here. So, and then I'm going to go ahead and say that I would like to sync this up. But this thing won't let me sync to master. So let's go to command line. Sorry, 11. All right, so what I did here, I'm going to zoom in to show you, is that I've created a local branch. So when I did a commit inside of VS Code, I'm not a great user of VS Code, so it's probably my fault. It didn't realize that I wanted to commit here, and I have a policy against master. I don't allow commits to master. So this is how Microsoft actually builds our software. So I wanted to demonstrate that flow. So I have a new branch. In this case, over command line, I was able to commit code to that new branch. So I'm going to go into VSTS and show you what that looks like now inside. I'm going to click on code. I'm going to select the correct repository. Again, you have unlimited repos you can create in here. So I'm going to select this repo, and I'm going to go to my commits. And, my pushes, branches. There you go. So under my branches, I have this branch, and it shows that there was a commit to it, and it shows that there's a new pull request available for this commit. Now, the reason why I have it set up this way is to protect my master branch. I want people to review the code that's coming in. So I'm going to show you how I prevented my code from going to master, how I messed up the first part there, is I'm going to go to branch policies. Branch policies is created out of necessity. We've had to create a bunch of stuff inside of VSDs to scale to the Windows team, really. They're the ones that drove a lot of these capabilities, and we've put this into the real product because, again, we build on the real product. We don't have a build system behind the scenes that's one system and then you guys get some other product from us. This is the real thing. They have all sorts of really challenging situations because of the 4,000 developers they have working on the same source code. But we don't have as many challenges, so I've just made one reviewer, and I've even cheated. I've allowed myself to be the reviewer, so I've required one reviewer to approve it before it goes to master. So I'm going to go ahead and actually go for that flow and show you our pull request experience. So I'm going to create a new pull request. In the real world, this would be going to some other people, but in my situation, it's just going to me. Right away, it's using whatever I committed to Git as my comments, as the thing. If I wanted to associate it right now with one of the work items I have, like let's say this was the one, it's not the one, but let's say it was, this is where the trackability starts to come in. I can do that here and make sure that there's a track back to the work that was assigned to me. So I'm going to go ahead and create the pull request. Not that the pull request has been created, I can, unfortunately for my company here, my fake company, I can self-review it, which is yay, I can do that. I can go in and I can take a look at what the changes were, and I can actually go back and clicking on here and see what the work item was. So there's a lot of linking back and forth. If this was the real work item, I'd be able to go back in and make sure that I understand what was the work that was expected before I do the pull request verification. And again, here I can see the files that were changed, so I can say, okay, that looks good to me. I can come in here and I can actually add a comment. I can do things like I can reference work items inside of the comments. So let's say I looked in here and something wasn't right, and I'm like, you're forgetting there was another task assigned that you didn't complete, that you should have committed as part of this set. So I could have done that here. Or I can do @ and I can add other people, and I can basically get an email to be fired off to them and say, hey, I don't think this looked right. Can you double check the code? Does that look right to you? So that's very powerful. Or I can just add markdown comments into this, and it's all saved. So like a year from now, you can come back and see why this pull request was approved and why, let's say you have a security bug in production. Not that that ever happens, but at least you'll be able to see what kind of happened historically. I'm going to say that I not only feel great about this, I actually want to auto-complete the approval process. I want the changes to be committed up to master. So I'm going to hit set auto-complete. I'm going to say delete the readme fix branch inside of VSTS. It's still available on my machine, right? But in VSTS, because we're merging from there, if the merge succeeds, it's going to kill it, clean it up. And I'm going to say, all right, so I feel great, autocomplete has been configured, and I'm going to approve it myself, which is, again, something you shouldn't be doing. But once I approve it myself, there you go, the changes have been committed. So if we go back to builds, we will now have a build running for the service, and it's running only because we went through that process. So as part of this demo, I've shown you a lot of stuff, but one thing I promised to show you at the end was this. There you go. It takes, I've sat there with a stopwatch, so anywhere between 8 to 12 minutes. If you get really lucky, it's like immediate because you're somewhere in that window of them waiting to check. But basically, this is where the Unity Cloud build picked up the changes that I made in VSTS to my Git repo, and it's now building inside of it. So between the Unity Cloud and our cloud, you can build Mono, you can build Unity. In our cloud, you can build C++, you can build Android applications. Again, we have Mac, Linux, and Windows hosted agents. You can have your own agents. You can configure it against other people's agents, like I did here. You really can do CI against your source code. Any problem you have can be solved pretty much with this product, at least we feel, and if we're missing something, we're here to make it better, so do let us know. And trust me, the Minecraft team is one team that I'm talking to actively because they have some suggestions, and we need to help them out there. So we will make this product better, even for our game studios being part of this, this product and making the solution. Thank you very much. If anybody has any questions, I'm available. Thank you.